Good day, everyone. Today, we are going to talk about one of the special types of a transformer, which is an autotransformer. So, in this video, we are going to discuss about the theory as well as the effective ratios included in an autotransformer. So, before we start, let us first have a quick recall of what is a transformer. So a transformer is a device employing the principle of mutual induction to convert variations of current in a primary circuit into variations of voltage and current in a secondary circuit. So meaning to say, we have two windings here. So by just looking at the diagram, we can see that the primary and the secondary windings are not directly connected to each other. However, compared to the first one, in the second diagram, we can see that the primary and the secondary windings are directly connected to each other. So it shows one single winding, which is one of the characteristics of an autotransformer. With this in mind, we can now define what is an autotransformer. So by definition, an autotransformer has a single continuous winding which is used for the input and output voltages. Hence, the supply and output voltages are not insulated from each other. So in simple words, in an autotransformer, the primary and the secondary windings are interconnected to each other, forming one single winding. So compare dun sa nauna nating napag-aralan ng circuit diagram ng transformer, makikita natin na yung primary tsaka yung secondary windings niya ay magkahiwalay. But in an autotransformer, we can see that yung special quality niya is yung primary tsaka yung secondary windings niya ay directly connected. So, may implication siya dun sa tinatawag natin na copper savings. Since an autotransformer is a special type of transformer, meron din tayong tinatawag na step down and step up. So, kung i-compare natin yung autotransformer sa ordinary dual winding transformer, magkakaiba lang sila doon sa circuit diagram but same pa rin sila nung working principle sa pag-step up at pag-step down. Since na-define na natin kung ano yung definition or yung kahulugan ng autotransformer, let us move on to the theory. So in this part, we will discuss about the variables involved in the circuit diagram of an autotransformer. So the N1 here in the diagram is the primary term. The N2 is the secondary term. I1 is the primary current. I2 is the secondary current. V1 is the primary voltage. And V2 is the secondary voltage. On the other hand, V1 or V sub 1 is the applied voltage, and the winding AC forms the primary winding, whereas the BC forms the secondary winding. So hence, the winding BC is common to both primary and secondary and results in economy of material. So, yung tinutukoy na economy of material, yan yung sinasabi ko na copper savings. So, malalaman natin yan through a problem mamaya. So, dahil tapos na tayo dun sa theory na under ng autotransformer, let us move on to the effective ratios. So, sa part na to, makikita natin or madidistinguish yung relationship ng mga variables na nabanggit natin doon sa theory. And we can also encounter some formulas that we can use to solve problems related sa autotransformer. So number 1, we have the induced voltage. So yung formula natin dyan is E is equal to 4.44 F which stands for the frequency, N which stands for the number of turns, and yung the omega symbol which means flux, and we can multiply 10 raised to negative 8 if the unit used is in Maxwell. So, itong formula na to is nagamit na natin siya dun sa nakaraang mga lesson. So, familiar na tayo dito. So, second, we have the ratio of transformation. So, same lang din dun sa nakaraan na topics. Yung ratio of transformation natin will be N sub AC over N sub BC. So, yung N sub AC is the primary winding, while the N sub BC is the secondary winding. So, the third one, we have the ratio of induced voltages. So, same lang din dun sa nakaraan. So, parang nagre-recall lang din tayo nito. So, yung induced voltage, E sub AC over E sub BC is equivalent also to dun sa ratio of transformation, which is equivalent dun sa N sub AC over N sub BC. And sabi dito, neglecting the voltage drops, V or yung V sub 1 over V sub T or the V sub 2 is equals to the ratio of transformation approximately. So, yung values nila is hindi naman nagkakaiba. Kumbaga, mas malapit yung values nila sa isa't isa. Kaya, yun nga, approximately. Next slide. So, it is said that when the transformer is loaded, a secondary current or the I2 flows in the direction assumed in figure 118 or 118. So, from Kirchhoff's law, as vectors, I2 is equivalent to I1 plus I sub CB. So, yung I sub CB is yung current from the secondary winding. So, I1 is equals to I sub AB. Therefore, I2 is equals to I sub AB plus I sub CB. And as in the ordinary transformer, the primary ampere turns must balance those of the secondary, except for the small magnetizing current. Hence, the relationship between the current and the number of turns would be the product of I sub 1 and sub AC equals the product of I sub 2 and N sub CB. So, pag inayos natin siya, magre-result siya sa transformation ratio equals sa ratio ng I sub 2 and I sub 1. So, those following equation shows that currents flowing through the various parts of the winding will have other ratios than those displayed for the load values. So, ito yung tinutukoy na mga equations. So, yung I sub 2 equals I sub 1 plus I sub CB and yung transformation ratio which is equal siya dun sa ratio naman ng I sub 2 over I sub 1. And by Kirchhoff's law, we can further expand this equation. I sub 2 equals I sub AB plus I sub CB. So, transposing it, we could get I sub CB equals I sub 2 minus I sub CB. So, since ang hinahanap naman natin is yung ratio ng winding ng CB and AB, when it comes to the current, ratio ng current, we will have I sub CB all over I sub AB equals I sub 2 minus I sub AB all over I sub AB. Since I sub 2 all over I sub AB is equals to the transformation ratio denoted as A, then yung ratio ng I sub CB all over I sub AB would be the transformation ratio minus 1 or A minus 1. At kung ang hinahanap naman natin is yung ratio of voltages with respect to the windings AB and BC, this will be the process. So, yung equation E sub AC equals E sub AB plus E sub BC, kapag transpose natin ito, hanapin natin yung equivalent value ng E sub AB, could get E sub AB equals E sub AC minus E sub BC. So, from that equation, we could derive the ratio, which is yung E sub AB all over E sub BC equals siya sa E sub AC minus E sub BC all over E sub BC. And since yung E sub AC all over E sub BC is equals sa transformation ratio, then E sub AB all over E sub BC will be equal to the transformation ratio minus 1 or A minus 1. Sample problem. An autotransformer is required to step up a voltage from 220 volts to 250 volts. Total number of coil turns on the transformer main winding is 2000. Determine the total number of coil turns on the primary winding, the primary and secondary currents when the output is rated at 10 kVA, and the economy of copper saved. Given N sub 2 is equals to 2000 turns, B sub 1 equals to 220 volts, V sub 2 equals to 250 volts. So in this sample problem, we need to find the number of coil turns on the primary winding, the primary and the secondary currents when the output is rated at 10 kVA, and the economy of copper saved. So, dun sa una, since ang hinahanap natin is yung number of turns sa primary side, we will use this formula. N sub 1 over N sub 2 equals V sub 1 over V sub 2. So, deriving the formula for N sub 1, we will have N sub 1 equals to N sub 2 times V sub 1 all over V sub 2. So, substituting the given values, we could get 1,760 turns on the primary side. So, next, ang hinahanap naman natin is yung primary and secondary currents at rated output at 10 kVA. So, we will need this formula for getting the I sub 2. I sub 2 is equals to VA all over V sub 2. So, yung value ng VA is yung given na rated output, which is yung 10,000 VA or 10 kVA. Ang V sub 2 naman natin is equal naman siya sa 250. So, 10K all over 250 is equals to 40 amps. However, to find the I sub 1, we will use this relationship. So, P sub 1 is equals to P sub 2, which is equals to B sub 1, I sub 1 equals B sub 2, I sub 2. So, deriving for the equation for I sub 1, we could get I sub 1 is equals to B sub 2 times I sub 2 all over B sub 1. And then substituting the given values, we will have 45.4 ampere as the value for I sub 1. And lastly, in order to find the economy of copper saved, we need to use the ratio between B sub 1 all over B sub 2. So, B sub 1, which is equivalent to 220 volts, all over B sub 2, which is equivalent to 250 volts times 100% to get the percentage. So, in this sample problem, the answer would be 88%. So, 88% yung masasave natin na copper when we use an autotransformer. So, that's all for this topic, and thank you for listening. Have a good day.